how's it going? It's been like maybe like more than a month since I have joined here. Okay, so tell me about yourself. Sai, like, who is here? Okay, let me just first share my screen here. Okay, all right. So we are live now. Okay, so where are you from, guys? And how is it going in the after post pandemics era or season? Okay, so today we will going to learn about the machine learning, and I know like it's quite a bit of a hype here right now. Honestly, it is. But since we are learning about it, and let's see what exactly it is on a higher level, and then we will start to dig down as the day progresses. Okay, like for the next 5 days, and yeah, you will be having a better understanding of how exactly and what exactly machine learning does, and what else you can do. Like you certainly won't be becoming a hero after getting a 5 day session, but yeah, you will be having a good understanding about it. So how many of you here like have worked with the uh wait a second, first let me just bring the no let me bring the so is there anyone who have worked with the machine learning systems before, or any machine learning algorithms? Who is this, like Nigel Andre? uh I think this Nigel is somewhere from where, like ITM, right? And hello, hello everyone. Research paper. Oh, scikit-learn. So is there anyone who have worked like on any machine learning problem, or has any idea about what exactly it is? Yes, I have worked with machine learning. Great. All right, cool. Okay. So this is what we will going to learn about. It is totally for rookies, honestly. And let's see. Okay. What exactly it is? And when you think about machine learning, so what do you think? Like, can anyone tell me what and in their day-to-day lives, what application they have used in terms of machine learning? That like they have used a machine learning application by themselves. Like, is there anyone? Linear regression, linear algorithm, random forest, decision trees, gradient descent. Wow. Okay. Enamel. All right. House prices problem. Yeah. Okay. All right. So, what exactly is a machine learning, and why do we even need it in the first place? So, when we think of a machine learning algorithm, you might think like, okay, something like we are automating, and eventually we are, honestly, okay. And might be or also you might also think about some robot, a cool robot, which is taking over many or millions of jobs, right? And it is also true, but this is all over the on a level where you can see the application actually working. Okay, but exactly what is going on behind the scene is a total different scenario. Okay, and also a quite an interesting story to tell. And why do we even need it in the first place? Let's actually try to understand this with an example. Okay, let's say, let's say, uh, I usually, I okay, I have this. Okay, let's understand this. Okay, suppose you have been asked, like at your respective companies, okay, like you need to create or develop a spam filter. Okay, and you guys are pretty much familiar about the what exactly is this spam filter, right? Like what you use in your email in your email applications. Okay, like for your email you put an email if it is if it actually belongs to a spam or not. So how does a machine learning program will going to vary from your typical programming program, like typical Python program? Let's see. Let's say even if you write a program or like this is actually a pseudocode for writing or checking a subject's email subject. Okay, like which you put as a headline whenever you send an email to any of your colleagues or your prospective customers. So like I actually come up with a notion or understanding of whenever I see like this free for you, I would I will definitely going to declare this email as a spam. Okay. Well, there could be worse cases as well, where you might also find, like, you just have won a lottery, Nigeria princess, giving you $20 million. Okay, that is also a spam. And if you don't find those words in your corpus or in your email, you would declare that email as a not a spam. But all right, so maybe this time it worked, and somehow the fraudster actually get to know, like, all right, like, free for you, and for you may have flagged in your Python's program. Why not actually change this free with a smaller case free, right? So they can literally make millions of tweak in us, in a fraudster, in a fraudulent system. Okay, like, for sending with spams. And you can never, like, you will always run out of the solutions, you will always going to run out of the principles, or whatever the logic that you may put behind in order to classify if an email is a spam or not. Okay. Okay, so what exactly it is, like, what exactly the problem with this? Let's see. So, like I just explained you, okay, so this may you again write a program. So in this, right, so basically whatever the story that I have told you by now, like, this is what it is. So that's where actually machine learning shines. So what you do, you basically come up with a universal approximation function, or I would say a mathematical function, okay, that could separate or that could fit the data. Like, we usually define training as fitting the data, and that fit actually occurs with by defining or creating a model. Your model is nothing but a mathematical notation by having several degrees, like y is equals to mx plus c is also a is also a machine learning model. Okay, so what exactly it is, if I just some just slide over some previous if I slide my previous, like, previously here. Okay, what exactly is a machine learning? Like, when an algorithm learns from the data, the data here is your subject or your email that you are gathering or you are accumulating with the help of what, like, basically you are accumulating with the help of fraudsters apparently, right? And now you are trying to use your standard Python or any programming language approaches, and you are trying to rule out or trying to just define certain rules in order to flag an email if it is a spam or not a spam, right? So, like, that is why I wrote here, you come up with a mathematical function such as y is equals to f of x, but not always necessarily, right? Because we do have different types of machine learning systems, like, which we will just going to cover in a while. Okay, and where x is a feature vector, I will going to cover this, what exactly is a feature vector. But let's stick with the basic notions here right now. Okay, what do I mean by that? In machine learning, your machine learning algorithm does nothing but learns from the data itself, and it tries like, we try to come up with a mathematical notation or mathematical notion or a function that could separate or that could predict, that we the term that we use, estimate or predict the outcome, or based upon the features. Like, for me, let's consider an example. Like, what if for me, let's say here, come here, Jamboard, at the Jamboard. Okay, and come here. Okay, and now let's see, like this. Let's say, since we are in India, let's suppose, okay, we want to make a plot. Okay, and we have two types of ethnicities here. One could be Caucasians, and other could be Indians. All right, so let us say, what I want to determine based upon my ethnicity, or height, weight, or maybe hair color. Like, sorry, I do have, like, I could have, the as a Caucasian, my skin would be like in white, right? My hair would be more like more tend towards be like blonde. And also, like, Caucasians or other Western countries, like men are there like quite taller than the in India, obviously. Okay. So what I want to predict here, I want to estimate if based upon some features, features, let's say height, blonde, like color hair and everything. I want to predict like if the person is a Caucasian or an Indian, right? So we have certain rules here, like I need to check for the maybe for the hair color, maybe for the height, maybe for like maybe even for the eye color, because Caucasians or Western countries do have different eye colors than we do in India. Okay. So you cannot write each and every single rule in your Python program. Like you can, but it won't be feasible or scalable. So what you do, you basically take that data and you come up with a simple model. Like this is your model, and you put that data and like you put that model in such a way like where you can separate this. Let's say these circles are your Caucasians and these minus are your Indians, like these hyphens. And there could be some noise for sure, like like whenever someone says like my machine learning model predicts, like my machine learning model's accuracy is 100%, like never actually listen to that guy or a girl. Okay, like there is no model which can predict 100% accurately, never it does. All right. Okay. So yeah, this is what we come up to, like what if like we could have n number of features. Right now I just defined 4. Like if we could, I could have like 40. Like for example, like I don't know if you have worked with the Hendrik, like for the folks who have like said like yes, we have come up with, or they have actually worked with the machine learning systems, or MNIST data. Like okay, so I believe if you have heard about the MNIST data, like that data has around like 784 dimension or 784 features. How exactly you will going to write rules for 784 features? Well, in that case, like it won't be feasible or scalable either. You have to come up with a better approach. Well, that approach is machine learning. Okay, let's move forward. Right. So that this is your machine learning approach actually usually looks like. So what if we actually come up with a mathematical function that can separate spam emails from non-spam emails, as shown in the diagram, right? And this is usually what we do. And believe it or not, your spam filter was the very first machine learning algorithm, maybe back in like 1994 or 1995. Okay. So like all right, we saw how exactly machine learning actually we can actually leverage the power of machine learning here. But in what application and or in what domains, right? Because if you see machine learning only works upon the accumulation of data. The more you data you will going to have, the better, or yeah, you will going to make the predictions. It is true to some extent. Yeah, it also matters upon the data's quality though, but just actually I'm talking about on the higher level. So for the machine learning systems or for the machine learning applications, we can define or we can leverage the machine learning power in several domains, be it healthcare, be it computer vision basically for recognition of vision systems, like for the facial recognition, maybe for the pose estimation, maybe for the real-time movement analysis. Okay, even for the NLP and NLU, natural language processing and natural language understanding, for making smart chatbots. All right, for even for recommending recommendation systems. You might have actually watched maybe for Prime, Amazon Prime, or Netflix.com. Okay, whenever you see a manga or an anime movie, Netflix recommendation system will going to start recommend more and more anime to you. Why? Because like there is a thing called matrix factorization going on behind the scenes, and this is where you are getting recommendations. How do you get the what we say, a mutual friend request? Like I believe you may have actually noticed a notification in your Facebook notification bar or a bell. Okay, like you may know this person, right? Or like the notification for if you know that person or not. How exactly Facebook recognizes like if you could belong to that person or not. Like there's a thing called again link prediction. Okay, graph link prediction. Again, image restoration. I know you may have also seen those applications where, like, maybe for back in 1815 or back in 1715, which we have colorized with the help of deep learning, and so on and so forth. There's also a cool website called thispersondoesnotexist.com, and that application uses under the hood GANs, journal adversarial networks, that can create those faces which never existed on this planet Earth. Can you see how cool and terrifying at at the same time, right? So yeah, like machine learning or deep learning is cool or terrifying at the same time. Okay, and yeah, so let's try to understand by what type of machine learning systems that we can create. Like we saw what type of machine learning, application that we can leverage, in terms of domain knowledge, right? Like be it computer vision in healthcare, in NLP, recommendation systems, image restorations, so on. Okay, but does all the machine learning tasks are all the same, or do they differ from each other? All right, this is what we need to study about now. Okay, yes, they do differ from each other quite a lot actually. Okay, let's try to understand this with these three. Like we do have other we do have other machine learning methods as well, like we call that batch and semi supervised and online learning. But let's stick with the most popular three. Like you people may find like, okay, I didn't cover that those three, but yeah, I'm just giving you a disclaimer here. Like these are the three which are most used in industry. Okay, so let's stick with these three right now. Okay, supervised, unsupervised, and reinforcement. Okay, okay, all right, let's focus here. What exactly is a supervised machine learning? Okay, when we have a label or a class to predict, that's it. That is actually a supervised machine learning algorithm. Let's try to understand this more. Let us suppose you have been given a task of predicting a house price, like as someone mentioned in chat. Like based upon the lot size, garage area, maybe the location of the your house, or maybe the land area, or how old that house is, you may want to predict the house price. So what you can do, you can just leverage the power of machine learning, and you can come up with a model, okay, that could predict the house price there. And in this case, house price is a label. Okay, all right. We could have another type of example, like let's say if I want to detect, or if I want to classify, if an image is from, like if an image is of a dog, or of a cat, right? So well, in that case, again, what you can do, you can, like, there is a thing called pixel classification as well. Okay, and also image classification. Well, in this case, we will going to perform image classification. Basically, pixel classification is for the image segmentation. It just came out really wrong in that context. Okay, so in this case, what we can do, we can take pixel values of each image, classify them, extract the features from each image, and can train our model, and then we can make an image classification model that could classify between a dog and a cat. Okay, so let me ask you a question here. Let me see, okay, if you can answer it or not. Let us say I have this, I have like 1.0, let's say 1.0, then 5.0, 1 till 5. And I would say here, let's call it x1, and let's call it x2, and this x1 belongs to r, and this x1 belongs to I, x2 belongs to I. So can anyone tell me, like, how many numbers are there, like how many numbers do you see from 1.0 to 5.0, and how many numbers do you see between 1 to 5? Can anyone tell me here, how many numbers do you see between 1.0 to 5.0, and how many numbers do you see between 1 to 5? Whereas x1 actually belongs to r, and x2 belongs to integer values. Aditya is saying 50 and 5. Anyone else want to try? Okay, I am just giving you 30 seconds, not more than that, because we are running out of time already. Yes, Saurav is right. Saurav Jyoti Sakya, he is right. Infinity and 5. The first value, the first range actually contains infinite values, and this only contains 5 values. So that actually brings a new like this actually brings a new thing here. Okay, for here regression predicting is continuous output. Now we are studying about the supervised machine learning algorithm, and in that we have another hierarchy for regression and classification. And I just defined what exactly is a regression is: predicting and predicting continuous output, or classification is predicting a class. Okay, so what exactly is a continuous output? Your continuous output is nothing but a real world value. Okay, and like people who are actually wondering like how exactly it could be infinite, let's say like if even if I say like there are infinite numbers between 1.0 and 1.1, like that, this statement is still correct. All right, but not for this. Like I don't know if you do remember the step function. Like, do you remember that step function in maths, like the which used to go like this? Step function. How many of you remember this? Right. And your continuous function could be anything: your sine wave, your cos wave. Okay. And yeah, your sine and cos wave actually starts from let's actually not talk about the sine and cos. Let's actually talk about the tan here. Okay, tan actually starts goes from minus infinite to plus infinite, right? Okay, so yeah, so what is your regression again? Your regression is nothing but predicting a continuous output. Okay, whereas your classification is nothing but a predicting a class, and your class has to be cardinal. What do I mean by the cardinal here? And like you should always check the cardinality. Like, sorry, since I am defining what exactly the classification is, you should also know about the cardinal values and what exactly is the cardinality. Okay, let's see. So your cardinal values are nothing but the number of unique values in your in your feature, in your row vector or feature vector. Like, I will going to define what exactly is the row vector and feature vector, but let's actually see those values as array. Like, for this 1, 2, 3, 4, for this array the cardinal value is 4. Why? Because it does have 4 unique values. Okay, so whenever you try to make a decision about, like, if this machine learning system or if this machine learning task belongs to regression or classification, you need to take care of few parameter, or you need to do due diligence in order to define a machine learning task, or in order to define a machine learning algorithm. Like, which algorithm you will going to opt for. It does matter, right? All right, so I hope this is clear to everyone what exactly is a supervised machine learning algorithm. Is it okay? Let's move forward. Okay, and with the next one, unsupervised one. Okay, so what exactly is unsupervised machine learning? Like, okay, let's see. Like, when we don't have a label and want to predict a query out of a cluster or segment or a group. Why am I saying it? Like, let's just for a while forget about what exactly is the machine learning algorithm. Okay, just for a while. Okay, consider a scenario where you have made transactions through your credit card, like maybe for a year, and like you have made around like maybe 300 transactions from your credit card. Okay, from those 300 transactions, you used, secured gateway system. You use secured whatever the payment gateway you might have used on, like on any restaurant or any malls, right? All those transactions were declared as, what we say, uh, not non fraudulent. Sometimes actually I lack on words, sorry for that. Okay, okay, non fraudulent. So now what happens, like, since we don't have, like, we can only make a cluster. Like, what I can do in this case, let's say what do I mean by that? Let's say I actually make this. I have this range from 0 till, let's say, 2 lakh rupees. Okay, and this is somewhere around like 1 lakh rupee. It is quite common for me to make a purchase between these range. A lot common. Okay, let's suppose, like, in this, from 0 to 1 lakh, I have made most of my purchases. So out of the blue, one day, what happens on a certain day, like, someone actually, your card shows a transaction of 1.75 lakh, just actually crosses this limit somewhere here. Well, in that case, your card will be blocked for sure if you do have it. Okay, and you will be, you will be called by your, maybe from your branch, from your bank's branch. Okay, like, you make that transaction, did you use that, etc., etc., in order to make sure, like, if it was a genuine transaction or not. Well, this algorithm actually fits in more anomaly detection. Okay, this is actually your anomaly detection. Please pardon my handwriting here. Even if I actually write with the pen, it doesn't go really well. Okay, uh, okay, anomaly detection. Okay, and other than that, let's say I want to determine, based on, let's for that example, let's say, uh, what if, like, I don't know, let's say, yeah, that is actually, I have the data set of, let's say, from 1 to 10. Okay, sorry, 0 to 9, not 1 to 10. 0 to 9. And now what I want to, cluster all zeros, all ones, all threes at a one place. So what I can do, like, this is actually a dimensionality reduction problem. Well, and this is also an MNIST dataset problem. Okay, quite a hello world problem in machine learning. All right. So what we can come up with, like, this 0, we can come up with a cluster here 1. We can come up with a cluster with 2, 3, 4, 5, 6, 7, 8, 9. The overlaps that you are seeing, okay, for this, let's suppose, like, this is actually 4 and this is actually 9. These overlaps are your errors. Like, your algorithm might have predicted 4 as 9 or 9 as 4. But what you did, you literally performed the clustering algorithm. You segmented a lookalike data point in a cluster. Well, in this case, we have nothing to predict, honestly. Okay, all we can do, make a segment, or make a cluster out of our data, and do some analyzing, and or we can do some observations. Okay, this is your unsupervised one. What do I mean by that, an unsupervised one? When you don't have a label. Okay, all right. And the funny thing is, let's say, mm, even if you don't want to predict, like, let's say, even if you don't want to predict with this 0 to 9, you can certainly make, this actually problem can be tackled in a two-way, honestly. Like, since the cardinality value is right now 9, the unique value, number of unique values is 9, which is quite low, and you can certainly perform here classification task as well. Okay, so it is also not a hard and fast rule. Like, it could be, like, we could literally make a problem into several machine learning problems. Like, we can divide it, like, in other tasks as well. All right, cool. Let's move forward here. This was your unsupervised one. Okay. Now comes the most interesting part, which is what we say, reinforcement learning. Okay. What exactly is a reinforcement learning, and how does it work? I don't know if you have pet or not, but if you do, okay, like what you usually like, how exactly you would go for training a dog. So you will going to train a dog according to the behavior that you find correct. Okay. So let's suppose this scenario, like on maybe there is a dog, and what you want to do, like you do not want your dog to poop in your house anywhere. Like obviously no one does. All right. So what you do, like you whenever your dog like poops in your house, like you will just going to scold that you will just going to scold your dog, like bad dog. Okay. So like that is actually a negative reinforcement, telling your dog like this is bad. And whenever he poops outside, outside of your house, definitely not in front of someone's house, okay, you treat him with a biscuit or with a cookie. That is actually positive reinforcement. So in this case, this machine learning system is nothing but a training an agent based on rewards. Okay. And your reinforcement learning works like whatever the correct behavior you find for your agent, you reward it with a positive, you reward it positively. Otherwise, you will going to reward it negatively. Okay. And the strategy usually are called policies in reinforcement learning. Fair enough? Okay. All right. Okay. So these were your basic machine learning algorithms. Okay. And I think like so let's try to understand now the workflow of how exactly a machine learning problem should be approached. Like most of the time, uh, like this is what you can always do, even if you are a beginner, or even if you are an advanced on an advanced level. If you are an advanced level, like you would certainly perform these steps. If you are a beginner, you can definitely follow these steps. Okay. So let's move forward. Okay. How exactly? Okay. And let's see. Mm, Machine learning workflow. How exactly it goes? Let's see. So you basically accumulate the data. I would call it accumulation of data. Okay. I will going to write it here. Data accumulation. Then even before the data accumulation, let's say this is actually your uh, understanding the business problem. Let's understand this. Understanding. Like this is actually important. Like a lot. It doesn't matter whether you can perform a lot of operations on a matrix. Like machine learning is nothing but linear algebra. Okay. And doesn't matter. Okay. If you don't understand the machine learning business problem, and like you should also ask yourself, like if this problem can be tackled even without machine learning, even without using the machine learning or not. Because believe me, when you are tackling a problem which is new to machine learning, it will be a pain, a clean, simple pain. Because you would not find the suitable data, you will be having a problem by labeling that data. Like, okay, and like other obstacles as well. That data won't be as structured as it should be. But that is actually again a machine learning, task that that you may want to perform and that you may need to perform. Okay. Understanding the business problem, and the second is basically what the moment you understand the business problem, the second thing that you might want to ask or you might want to do is getting get the data. Okay. All right. Next thing is this. Once you understood the business problem, and also you have accumulated the data, then you would perform, like, this is obviously the higher level. Okay, we do have some sub steps as well, like another hierarchy as well in each of these steps, but I am skipping over those and just giving you a bigger picture how I would actually approach a machine learning problem if I just have to start right away. Okay, getting the data, then the next thing that you may want to perform is the EDA. Like, without performing an EDA, like, it is next to impossible to build a good model, because by doing the analysis, like EDA stands for exploratory data analysis, by doing the analysis or doing exploratory data analysis, which we also say, okay, then and only then you will going to know, like, all right, like, these features may be redundant, or maybe these features are not that redundant. Then and only then you will gonna know, like, maybe these features need some sort of feature engineering as well. Okay, so EDA is an important thing. Okay, say it as a EDA. All right, that is your EDA. After performing the EDA, the next thing that you may want to perform, I'm saying may, because sometimes it is necessary or sometimes it is not, but yeah, data pre-processing. Okay, I'm just calling it a DP, data pre-processing. After performing the data pre-processing, okay, this is where your data pre-processing is something like removal of your outliers, also cleaning the data which is missing, or maybe filling that data which is missing, and also normalizing the data, standardizing the data. These all steps comes under the data pre-processing. Okay, this is only for the numerical data which I just talked about, the processing steps. And we, for the categorical ones, we have one hot encoding and embeddings and etc etc. Okay, let's not go there right now. Okay, yeah, but for the categorical you usually perform one hot encoding. Okay, and then you prepare your machine learning algorithm, then you prepare the data, preparing the data for ML. Once you prepared the data, like, now you have, like, yes, your data should always be in a numerical format. Just remember this. When you have prepared your data will be a matrix. Your machine learning data, in the end, prepared data is always will always be a matrix. And that very data, and yes, that matrix should not contain your labels, right? Because if you will going to include that label into that matrix, well, satyanash ho gaya, right? All right, so after performing, like, after when you prepare the data for machine learning algorithm, now is the time for training your model. Once you trained your model, now you may want to look, oh, all right, like, this may require some sort of fine tuning. Well, in that case, what you can do, again, you will going to do, like, this loop will going to look like this. And let me actually draw it somewhat good. Okay, train, I will just going to tr model. Okay, train ML. And after this, like, this model, like, train ML, and this should actually have, let's say, two steps here. Okay, if the accuracy is according to, or if the improvement is according to your needs, then you should exit. Else you should again train your model by hyperparameter tuning. I would call it hyperparameter tuning. So that is how your machine learning model, or training actually looks like. Okay, and each step has its own set of problems, and has its own set of challenges. Okay, so let's perform, and let's actually do some sort of real world data or machine learning thing here. So for the overall period of, like, for the next 4 days, or maybe yeah, today is the first day, and for the next 4 days, the problem that we will be tackling is the Kaggle problem, the Titanic data set. Okay, so let me brief you about what exactly it is. Okay, so this is the data set. So what it is all about, like, we will be tackling this problem with our own taste. Okay, and let's see. So we will be performing each of these step here. We will be performing data analysis. We will be understanding the business problem. Let's actually try to understand the business problem just yet, and then we will going to get the data, then we will perform the EDA, then DP. What exactly the DP? Data pre-processing. Then we will going to make the data model ready for machine learning tasks. Then we will going to train it, optimize it more. If it is cool, like, okay, if it is right, then we will going to deploy it, or make it inference ready. Otherwise, we will going to train it again. All right. So what exactly it is all about? Let's see. Like, for the Titanic data set, you have for the data here. Okay, and for this we have a lot of what we say columns here. I don't know why it is showing only. Just come here. For the train.csv, we have a lot of columns here. Okay, for the passenger ID survived, we need to define, or we need to find, like, if the passenger was survived or not. Okay, this is your label in this case. Okay, and this is what we want to predict, or like you can also consider, like, this is nothing but a binary classification task. So as the day, like, as we will going to progress, I will going to make you familiar with how exactly machine learning workflow under the hood actually looks like. And yeah, like, the loss and everything, the gradient descent. Okay, and then certainly you can tackle it. Then we have P class, then A, like, whatever it is, sex, age, SIB, sibling, something it was, I believe, like, if I remember it correctly, ticket, fare. Okay, based upon these, okay, we need to calculate, or we need to check how we can predict this. Let's do this right away. So what I want from you guys, like, we do have some minutes. Okay, so what I want you from you guys, like, I like, before leaving this session, I will going to give you a notebook right away. Okay, like, you need to prepare it for by yourself, but I will just going to give you how the instructions, how you can prepare it. Okay, and sign up for this Kaggle, or else what you can do, you can yeah, like, sign up for this Kaggle platform. Like, I just don't want to make this anyone's, like, for this any hard. Okay, sign up for this Kaggle, go in here, code, create a new notebook. Okay, and you can see, like, okay, Titanic data set. Let's upgrade. Okay, like, I do not want you to go through any of the installation thing, like, this usually sucks. And yeah, like, you will be having pre-built pre-built environment online, where you can perform whatever I will be performing here. Okay, which I will do from the tomorrow session. Okay, and let's see, let's actually try to understand this environment first. Shift enter, perform shift enter. So how many of you have here Python experience, like, they have coded in Python before? Is there anyone? Anyone? No one? So let's do it. I have a habit of defining libraries when they are needed. Well, in this case, uh, we only need to understand the data first. Okay. Yeah, all we need is basics, sort of. Himanshu is asking, is this required to be a software developer? Himanshu, first thing is machine learning engineer and software developer is totally like a different path. Certainly, you can become a software developer by having a knowledge of Python programming, like for any like any programming for that matter. I usually don't generalize based on programming languages, but yeah, okay, all right. So okay, so let's perform this. So like I know it's still taking some time. I don't know why. Okay, all right. So we are good to go. Okay. So this is where our train.csv is. This is test.csv is. Let's actually ignore this one. Okay. So let's copy this. I have this habit of doing it. Okay. df pd dot, and I would actually write it here. Knowing the data or exploring the data. Not doing the analysis though just yet, but exploring the data. pd dot data frame, or no, read csv. Okay. So this is actually the path to your train.csv. How else you can get this path? You just need to copy this file path and like you shall get this very path here. Okay. Is machine learning necessary for graduate students studying bioinformatics? Kayod, is it's quite a vague question to be asked honestly. Is machine learning necessary for graduate students studying bioinformatics? I would like to respond to that as if your curriculum does have machine learning, then it is necessary. And if you are just exploring machine learning domain, like then like you should not worry about if it is in bioinformatics or not. Uh, I don't know why it is taking so much time. Okay, let's see. If had- so how many of you have here like used pandas, matplotlib, or seaborn? Is there anyone? Like how many of you have used pandas, matplotlib, or seaborn? I can, like I don't think so, Naveen. You can add it to your resume. You should add it to your resume, like your projects, your case studies, not this 5 days session. I wouldn't recommend it. Okay. Pandas, numpy, किस किसने किया है बताओ? Anyone here who has slightest idea about what exactly the pandas and numpy is? This is the console. Wow, this is weird. Okay, so what exactly it is? Like df.head. Like this head you can relate to your SQL head. Like it only brings up the 5 rows initially, like from your data frame. Okay, and these are the columns. Like this is the column. And if I actually show you, like I don't know why it is showing up here. Wait a minute. DN. Okay. So what exactly the df dot head does? It brings up the five heads from like five rows from your data frame. Okay. And how exactly your rows actually looks like I will be performing here a Linux command. Okay. Like this is actually a Linux command. Cat and Kaggle input train.csv. Your train.csv actually is here. Okay. Run this. Now you can see right now. Okay. Like here, passenger ID survive P class. I hope this is visible to everyone. Okay. So this is in your train.csv file. Okay. Like this is nothing but your comma separated file, which we also say like, okay, train.csv. So this is your parent passenger ID survived P class name, sex, age, sibling, SIB, SP, parsh, etc. etc. Okay. And yeah, okay. So that is how your train.csv actually looks like. And if I do here head, okay, so this is your first 10 values from your train.csv. So under the hood, that is how your train.csv looks. But when we read this from the pandas data frame, like that is how it looks. So this is in machine learning is often addressed as a data frame. Okay. So what I want you guys from, like, you should not worry about installing or setting up an environment just yet, because it can confuse you at a beginner level. Okay. So just actually stick with the online version of Kaggle. Like they are quite fast, and if you see their RAM capacity, okay, like they have 16 GB of RAM, which is quite good. Okay, and also they have the capacity of 73.1 GB of disk, so we should be pretty much good to go with this. All right. Okay. So yeah, so let's actually do some sort of more knowing about the data. So if you notice here, like I do have 891 maximum number of columns here, 891 passenger ID and etc etc etc. But I do have some values which are missing, like for this age and for this 204. Don't worry, we are just knowing the data right now. Like we will going to perform these steps again in our tomorrow's session. So just don't worry about it yet. Okay, let's actually see like how much of the data is actually missing. So is na dot sum. All right, so we have 177 values missing from age row. Sorry, like age column, not the row. We have from this column, we have missing around like, you know, 177 values. And for the cabin, like we have, okay, almost like if we want to see the value of cabin, there is a way to do the percentage here. You can do length of def. 77% of data for cabin is missing. Like I also can do this. Okay. And from the age column, we have 19%, almost 20% of data is missing. So we will going to tackle these columns as well for the age and for the cabin and also for the embarked. Like 22% data is missing. Like sorry, 0.22% is missing. All right. So we will going to tackle that as well. And for the cabin, there it is. Age is all right. Okay. Okay, so yeah, so let's deal with this tomorrow, and yeah, we will going to come back like where we left from. Okay, so now this is it for today. So we will going to continue from this very like from this very step where we are living right now, and I shall see you tomorrow. So if you do have any questions, then please ask. I will going to answer those. Hey Abhiram, I do remember you. How are you, man? How's it going? How do you determine what percentage of missing data is critical? Like it matters on several factors. Okay, like how do you what percentage of, let's say for, if the data is more than 80% is missing, or maybe 90%, in that case I would like to, just drop that entire column itself. That This is what I usually do, because filling up the data based upon some strategy, that strategy could be anything. For the categorical values, it could be, filling the values with the most frequent ones. Okay, this is what I am doing with this cabin data, because this actually doesn't crosses the threshold of 85 to 90% of the data which is missing. Well, we do have data which we can fill with the cabin here, like with the cabin's most frequent value, which I will be doing. And for the age, it is only 19%. So when the data is missing about, let's say for 90% or 90 or maybe 85, more than 85%, well, I will start to pondering over if I should drop this data or not. But certainly if it crosses the 90% threshold, well, in that case I will going to drop it. Okay. All right, guys, this is the time where we need to say bye. Okay, so I will see you tomorrow. Okay, and till then, chill, watch Squid Game. I believe it's quite dope, right? And I will do the same. Okay, bye bye. See you.